Today we are going to learn about mastering RESTful APIs for machine learning integration. We will explore how to set up, test, and deploy RESTful APIs to seamlessly integrate machine learning models into applications, ensuring robust and efficient interactions. Welcome to our session on mastering RESTful APIs for machine learning integration. In this video, we'll dive into the essentials of RESTful APIs, which stand for representational state transfer. They are a set of rules that enable programs to communicate over the internet. RESTful APIs are crucial for application development as they allow different software systems to interact seamlessly. This becomes particularly important when integrating machine learning models into applications, allowing for efficient model deployment and interaction. We will go over the fundamental components of a RESTful API, such as endpoints, methods, and status codes, setting the stage for the detailed exploration that follows. By the end of this tutorial, you will have a thorough understanding of how to set up, test, and deploy a RESTful API, making your machine learning models accessible to applications. To truly master RESTful APIs, we must first understand their core principles, which revolve around the REST architecture. REST, or representational state transfer, defines a set of constraints and principles for building web services. One of its foundational concepts is statelessness, meaning each HTTP request from a client to server must contain all the information the server needs to fulfill that request. This allows for scalability and resilience in web applications. Another key aspect is resource representation. In REST, resources are identified by URLs, and each resource can have different representations like JSON or XML. CRUD operations, create, read, update, and delete, are implemented through HTTP methods, post, get, put, and delete, respectively. Understanding these operations is crucial for designing APIs that can handle various interactions with machine learning models. Effective API design also involves choosing appropriate endpoints and status codes to ensure clarity and usability. Status codes like 200 OK or 404 not found provide essential feedback about the request's outcome, aiding in debugging and user experience. By grasping these fundamentals, you're laying the groundwork for building robust and efficient RESTful APIs.
Now that we've covered the fundamentals, let's set up a simple RESTful API using Flask, a lightweight WSGI web application framework in Python. Flask is an excellent choice for developing APIs due to its simplicity and flexibility. To start, you'll need to install Flask. This can be done using pip, Python's package installer, with a command pip install Flask. Once installed, set up a virtual environment to maintain clean dependencies. With your environment ready, you can start creating basic routes. In Flask, routes are defined using decorators, and each route corresponds to a specific function. For instance, you can create a route that returns a JSON response by using the JSONify method. This method automatically converts your Python dictionary into a JSON object, which is the standard format for API responses. To test your API locally, you can run the Flask application using the command flask run, which will start a local server. Accessing this server through a web browser or a tool like Postman will allow you to see your API in action. This practical setup forms the basis for deploying machine learning models as RESTful services, which we'll explore next. With our Flask API setup, the next step is to deploy a machine learning model as a RESTful service. This involves integrating your pre-trained machine learning model within the Flask framework. Start by loading your model using a library like TensorFlow, PyTorch, or scikit-learn, depending on your model's format. Once loaded, you'll need to create an endpoint specifically for predictions. This endpoint will accept input data, process it through the model, and return the predictions as a JSON response. For instance, if you're working with a model that predicts house prices, your endpoint could receive features like square footage or number of bedrooms, and return the predicted price. This setup allows applications to request predictions by sending HTTP requests to the API. Deploying models as RESTful APIs has several advantages. It abstracts the complexity of machine learning models, making them accessible to other applications and users. Additionally, it allows for easy scaling and updating of models without changing the application code that uses them. This separation of concerns is a key benefit of using RESTful APIs for machine learning integration.
In RESTful APIs, JSON, or JavaScript Object Notation, is the preferred data interchange format due to its lightweight and easy-to-read structure. Handling JSON data effectively is crucial for smooth API operations. When a client sends a request to your API, it often includes data in JSON format. In Flask, you can parse this data using the request.get_JSON method, which converts the JSON payload into a Python dictionary. This allows you to easily access and manipulate the data within your endpoint function. When returning responses, the JSONify function in Flask automatically converts Python dictionaries into JSON objects. It's essential to validate the input data to ensure it meets the required format and content. This can be done manually or using libraries like Marshmallow for schema validation. Following best practices for JSON handling, such as setting appropriate content types and ensuring consistent structure, enhances the reliability and usability of your API. Proper JSON handling ensures that your API can effectively communicate with clients, making it a vital skill in mastering RESTful APIs.
Security is a paramount concern when deploying RESTful APIs, especially when integrating machine learning models that may handle sensitive data. Ensuring that your API is secure involves implementing various authentication mechanisms. One common approach is using API keys, which are unique identifiers assigned to clients making requests to your API. This allows you to control access and monitor usage. Tokens, such as JSON Web Tokens, JWT, provide an additional layer of security by encoding user information and are often used in authentication processes. It's crucial to use HTTPS to encrypt data transmitted between clients and the server, protecting it from interception by malicious actors. Additionally, following best practices like rate limiting, IP whitelisting, and regularly updating security protocols helps safeguard your API. By implementing robust security measures, you ensure that your RESTful API remains reliable and trustworthy, a critical aspect of its successful deployment. Thorough testing of API endpoints is essential to ensure that they perform as expected and handle errors gracefully. Several tools and techniques can be employed to test your RESTful APIs effectively. One popular tool is Postman, which allows for manual testing of API endpoints. With Postman, you can simulate client requests, observe responses, and diagnose issues quickly. For automated testing, integrating unit tests within your codebase is highly recommended. These tests verify that each function within your API behaves as intended, providing a safety net against regressions. Additionally, incorporating continuous integration and continuous deployment (C/CD) pipelines automates the testing process, ensuring that any new code changes are tested before deployment. This reduces the chances of introducing bugs into production. Comprehensive testing not only verifies functionality but also enhances the reliability and robustness of your RESTful API, making it a critical step in mastering API development.
As your application grows, so does the demand on your RESTful API. Scaling your API to handle high-traffic environments is crucial for maintaining performance and user satisfaction. One challenge is ensuring that your API can handle increased loads without degrading performance. Load balancing is a common strategy to distribute incoming requests across multiple servers, preventing any single server from becoming a bottleneck. Caching is another technique that can significantly improve API performance by storing frequently requested data temporarily. This reduces the need to repeatedly fetch data from the server, saving time and resources. When considering scaling methods, you can choose between horizontal scaling, which involves adding more servers, and vertical scaling, which involves upgrading existing server hardware. Both approaches have their pros and cons, depending on your specific requirements and constraints. Monitoring API performance using tools like Prometheus or Grafana, and optimizing based on insights, ensures that your API remains efficient and responsive. By understanding and implementing effective scaling strategies, you can prepare your API for growth and success.
Even with careful planning and implementation, issues can arise in your RESTful API. Being able to troubleshoot these problems effectively is a key skill for any API developer. Common errors include incorrect status codes, malformed requests, and unexpected server behavior. Identifying these issues often requires a combination of debugging techniques and diagnostic tools. Logging is an invaluable tool for tracking errors and understanding their context. By logging requests and responses, you can gain insight into what went wrong and why. Handling exceptions gracefully is also crucial. This involves providing meaningful error messages to users and ensuring that your API continues to operate smoothly, even when encountering unexpected input. Continuous improvement is achieved by gathering feedback from users and using it to refine and enhance your API. By developing strong troubleshooting skills, you can maintain the reliability and user satisfaction of your RESTful API, ensuring its long-term success. As we conclude our journey into mastering RESTful APIs for machine learning integration, let's recap what we've learned. We've explored the fundamental principles of RESTful APIs and how they facilitate communication between applications. Understanding these concepts is crucial for integrating machine learning models into applications effectively. We've covered the full life cycle of creating and deploying an API, from setting it up with Flask to handling JSON data and ensuring security. Additionally, we've delved into testing, scaling, and troubleshooting, equipping you with the skills needed to build robust and efficient APIs. Remember, the key to mastering these skills is practice. Continue experimenting, exploring new tools, and refining your implementations. The world of RESTful APIs is vast and ever-evolving, offering endless opportunities for growth and innovation. Thank you for joining us, and we encourage you to keep pushing the boundaries of what's possible with API technology.